Hello, hello. This lesson, we are taking a look at lesson 6 in your workbook, which is solve for unknown angles, looking at angles and lines at a point. Okay, so in this opening exercise, basically it's kind of asking you to think back to previous knowledge. They want you to determine the measure of the missing angles in each diagram. So if you take a look at A, X is the angle you're trying to solve for or look for, and all they give you is this 36. Okay, in B, they want you to find Y, which is the angle on the left, and all they give you is this 121 on the right. And then for C, they give you, or you're trying to find Z, but they give you 82 and 172. Okay. So take a minute if you kind of remember what's going on for each of those, and think about what facts you might have used about angles in order to solve. But if you're not sure, that's okay too, because that's what this whole lesson is going to be about. There's different pictures that look like these and trying to figure out what information we need or what information we know about angles in order to solve for these. All right. So for the first part of this discussion, it says two angles, angle AOC and angle COB with common sine OC are, and this is where we're adding in, they are adjacent angles if C belongs to the interior of AOB. So basically, in this scenario, they're saying they have an angle, and they call it AOB. And if there is a ray C somewhere on the inside, okay, these two angles, since they are next to each other, we would call those two angles congruent, or adjacent, sorry. Those two angles are adjacent. The next piece of information, it says the sum of angles on a straight line is 180 degrees. Okay, and two such angles are called a linear pair. So straight line is 180 degrees. These are called a linear pair. Okay, so meaning if I were to have a straight line and I were to have two angles joined on that straight line, those two should add up to 180. All right, the next sentence, two angles are called supplementary if the sum of their measure is, okay, so supplementary is when two angles add to be 180. Okay, two angles are called complementary if the sum of their measure is 90 degrees. Okay, but here's the deal. Describing angles as supplementary or complementary refers only to the measures of their angles. The positions of the angles, or whether the pair of angles is adjacent to each other, is not part of the definition. So you may have two angles that are next to each other, like in our linear pair here in the red. And we would know that those add up to 180. We could call those supplementary. However, we could also have two angles. If I go back to the supplementary part, I could have an angle like this and then another angle like this. And if I know their two measures add to 180, that's supplementary. But notice how these angles aren't connected. Okay, if they're not connected, they don't share a side. Same thing with complementary. I know that complementary is 90 degrees, but I could have one angle like this and another angle over here, and they may add up to 90, but they're not connected to equal 90. Okay, so those are just some scenarios or some pieces of information that ideally you should have learned about or talked about at some point, but that we just kind of need to remember in order to do our problems today. All right. So the first scenario, it says, in the figure, line AD is drawn. Or actually, hold on. I feel like there is something missing. Nope, I guess not. Hold on a second. Okay. Somewhere, and I don't know why this is in my book and not on your notes, but somewhere, oh, never mind, sorry. I see what's going on now. Sorry, my bad. Ignore that dull second. In the figure line segment AD is drawn, find the measure of angle DCE. So anytime you see this M and this angle sign, this means measure of angle. Okay, in case you haven't seen that in a while. And then DCE, those are the letters they're telling you in order to follow for the angle. So if I look at D, I go to C, and then I go to E, they're talking about this angle right here. Okay, the one that's included between those three letters. So I am looking for that angle, and they said AD is a line segment. Okay, well, I know that line segments are straight lines, and they should total to 180. The two other pieces of information they give me, okay, they give me that ACB is 72. They give me BCE. Well, they give me this little square right here. Okay, so ideally from the past, you would have to remember that little square means 90 degrees. Okay, so if I have two angles and I just need the third one and I know they're supposed to add up to 180, I can write myself a little equation. 72 plus 90 plus my missing angle equals 180. Okay, and from there I'd be able to solve for my missing angle DCE. So I can combine like terms, add 72 and 90, they would become 162. Okay, subtract 162 from 180. And then my missing angle, which is really angle DCE, okay, is whatever 180 minus 62 is, which happens to be 18. Okay, so angle DCE is 18 degrees. All right, and that's how we're kind of going to work each of these out. Like, what kind of picture do we have, and how do I know what kind of relationship the angles have? Okay, for the next part, it says the total measure of adjacent angles around a point is 360 degrees. So if I look at this figure right here, I don't have a straight line anywhere, right? I don't have 80 or 180 degrees. I also don't have any right angles, so I can't use that. So around this point right here, if I were to connect all these things around this point, so technically it would form some kind of circle, or those angles could form a circle, and the total in a circle is 360. Okay. So they want us to use that information to find the measure of HKI. So again, follow around. Here's H, here's K, here's I. We're finding this angle here on the right. And they tell me that one angle is 133 and the other one is 147. Total, I'm supposed to get 360. So I can add up another little equation again. 133 plus 147 plus missing angle equals 360. Combine 133 and 147, which should be 280. Subtract 280 from both sides. And our missing angle, which is HKI, should equal 80 degrees. Okay, and that's all we have to do there. Third example, so vertical angles. We haven't talked about vertical angles yet, but the thing you need to know is they have equal measure. Okay, they actually measure the same. Two angles are vertical if their sides form opposite rays. Okay, so basically it's demonstrated in this picture with the example. They want us to find angle TRV, so TRV, this one here on the left, but vertical angles should always be across from each other. Like they share the same vertex point, but they're kind of opposites. So if I look on the opposite side of this figure, SRU would be the angle that's opposite of TRV. These are what we call a vertical pair. Okay, so based on my little information up here, vertical angles have equal measure. Therefore, angle TRV would have to equal angle SRU, which is 52 degrees. Okay, So that's the rule for vertical angles. If you have a vertical pair, then they're always the same measurement. All right. So in this example set, there's 3 different pictures, and we're finding all these different angle measures. We're finding angle A, B, C, D, and E. And we want to kind of provide the reason. So basically our reasons are either 1, they form a linear pair, so they add up to 180. 2, they are all around a point. And so because they're at around a point, they equal 360. Or 3, they're a vertical pair, and vertical pairs should always be the same. Okay, so that's kind of what we're looking for in each of these. So for angle A is in this first picture, and it's the angle on the right. Okay, well, if I look at my figure, it looks like I have a straight line. I have this segment right here, this segment, and angles A and 145 are both on that line, so they should be a linear pair. So the reason linear pairs are supplementary. Okay, and remember, supplementary means that they add up to 180. Okay, so if I were to take 180 and subtract 145, that should leave me with A. A would have to be 35 degrees. All right. Next angle, B. If I look in my second picture, B is my top angle right here. And if you think of the whole picture, they only provide me with one other measurement, and the measurement is 40 degrees. Okay, so in order for me to find B, I have to use the 40. It's the only way I'm going to get a number. All right, well, if I look right here, these 2 angles happen to form, well, they look like a linear pair. They're right next to each other, and they're on this straight line. So I'm going to copy down this reason again. Linear pairs are supplementary. Okay, so meaning if I were to take 180 and subtract 40, that should leave me with B. So 140 degrees is angle B. Okay. The next one, angle C. Angle C is also in this middle picture, but now we're looking at the left side angle. Okay, so if you recognize a relationship between C and B, you can use that. Or if you recognize a relationship between C and 40, you could use that. It's completely dependent on whatever you see. I would say, since C is on this side, but it has a vertical angle, which happens to be the 40, I would say use the vertical angle as your reason. So vertical angles are equal in measure. Okay, or meaning they should be the exact same. So if the angle on the right is 40, then C has to be 40 degrees. Okay. All right, 2 more. The next one, angle D. Angle D is actually the bottom angle here. And depending on what you want to use, there's lots of different ways you could figure it out. You could use the fact that D is vertical to B. So if D and B are vertical, they should be the same. You could use the fact that D and 40 form a linear pair. So if you know that they're a linear pair, they should add up to 180. It is totally up to you how you find this. Okay, so I'm going to say it's a linear pair with 40 or angle C, which we've already found. It's a vertical pair with angle B. Either way, no matter if you're using the vertical pair or if you're using the linear pair, D should equal 140 degrees. Okay, so think of it this way. B and D should be the same if they're vertical. If B is 140, D has to be 140. All right, angle E. Angle E is in this last picture, and it's the angle on the left. And if you think about it, in this picture, it doesn't look like I have any straight lines given to me. And I don't have any vertical pairs. So vertical pairs are only formed around x's. Typically, they're not formed any other way. Okay, so these three angles are formed around a point, like just around one central point. And so I would say angles at a point they said sum, which we can do, sum to 360, which just means they add up to 360. Okay, so I know that E plus 117 plus 146 should equal 360. If I add 117 and 146, that should equal 263. So E plus 263 equals 360. Subtract 263 from both sides. Whoops. Which means E would have to equal 97 degrees. Okay, so like I said, that's kind of what you're checking with for each scenario or each picture. You know, if you can find a linear pair, it's 180. If you can find vertical pairs, they're the same. If they're just around a point, they have to be 360. All right, so for the following examples, the following exercises, some of them are given in straight line segments, but basically we're just going to find the measure of each angle that they marked. And it says to give a reason for your calculations. If you don't want to write that part down, that's fine, but it is important to kind of notice what's going on in each picture. Okay, so for angle A is on the right side of this figure. And if I have AB, or they tell me in the instructions, AB is a line segment, I should know that those two add up to 180. So 144 plus A should equal 180. All I'd have to do is subtract 144 from both sides, and A would have to equal 36 degrees. Okay, and the reason being is linear pairs are supplementary. I know that these represent a linear pair. Okay, for B, or for number 2, sorry. Number 2, I am finding angle B, but if I look here, segment AB is still a linear segment. This time I just have 3 angles. I have a 97, I have a 36, and then I have angle B that is supposed to add up and equal 180. So 97 plus B plus 36 should add up to 180. I can combine like terms, 97 plus 36. That's going to give me 133 plus B equals 180. Subtract 133 from both sides. Oops. Okay, B would have to equal 47 degrees. Okay, and so the reason for this one is that instead of necessarily saying a linear pair, we just have linear adjacent angles. Like we don't have a pair of angles, we have more than 2. So we would just say these 3 adjacent angles form a linear segment. All right, number 3. Okay, a lot going on here too. So I'm only looking for angle C right here. And I have another straight line segment from A to B. But this time I have 3 other angles. So I have 40, I have 36, and remember I have this little box right here, and that little box means that that's 90. Okay, so I know that 40 plus 36 plus C plus 90 should equal 180. Okay, so I'm going to combine like terms. So 40 plus 36 plus 90 should be 166. Plus C equals 180. I would subtract the 166 from both sides. And then that would leave me with 14 degrees for C. right, number 4. Okay, so this one's a little bit different. If you notice, I'm solving for D, but there's 2 D's here. There's a D on the left and a D on the right. Okay, now ideally here, if there's 2 D's, that means both of them should equal the same thing. And I would be able to put D plus 82 plus D equals, if you notice, they're on another line segment, so they should add up to 180. But combine like terms, D plus D, that's 2D, plus 82 equals 180. Subtract 82 to both sides. 2D would equal, that would equal 98. And then divide that by 2 because we want to solve for just D. D would be 49 degrees. Okay, so some of this is a little bit more algebra involved than what we had been working on, which hopefully some of you are a little more comfortable with. So don't hesitate if there gets to be some equations that we're writing. All right. For number 5, all right, number 5 doesn't happen to have any straight lines. Like there's no line segments I can use, so I know I'm not adding to 180 anymore. But look, I'm solving for angle G, but there are 3 G's. Okay, the numbers, the other numbers that we have are all the same. They're 91, 91, 91. And because I don't have a linear pair, I also don't have any vertical pairs. And with that, that means I have to use the whole around the point. So that means all around this point should total to 360. So that gives me 91 plus 91 plus 91. There's 3 of those. Plus G, oops. G plus G plus G should all add up to 360. Okay, so combine like terms. 91 plus 91 plus 91. That should equal 273. G plus G plus G, that should total 3G. Add it to 360, subtract 273 from both sides. 3G will equal 87. And then divide by 3. And G should equal 29 degrees. Okay, so that one you did kind of have to use the whole picture and understand what was going on all the way around that point. But once we did, we were able to solve for G. Okay. For the next few exercises, it says find the values of X and Y, and we're going to show all our work. So again, we just want to go through and make sure we can pick out what's going on in our picture. But now our problems are definitely going to look more like algebra problems. Okay, there's going to be a little bit more solving involved. Okay, so number 6, I actually only have to solve for X. But if you notice, I have a 2X for one angle and then a 1X for another angle, and then I have 85 and 35. Well, in this diagram or in this picture, I don't have any linear pairs. I don't have any straight lines, so I can't use that. I also don't have any vertical angles, so I can't use that rule. This is going to be where we have to use all around the point and add all these to equal 360. So I'm going to have 2X plus 35 plus X plus 85 equals 360. Okay, so go through and combine like terms. 2X plus X is 3X. 35 plus 85, that should be 120. Set that equal to 360. I'd be able to subtract 120 from both sides. 3X equals 240. Divide by 3. And X would equal 80. So X in our problem is 80 degrees. Okay. Now that kind of just depends on the problem too. Like if they wanted us to go back and find out what those angles were, well, the angle that's just X, that would be 80. But the angle that's 2X, we would have to take 80 times 2, and that would actually be 160. Okay, just make sure you finish the problem to whatever they ask. Here we're just solving for the variables. Okay. Number 7. So number 7 is an X and Y problem. All right, so you kind of have to figure out how to solve for one variable and without knowing the other one. It's kind of tough here. This one's kind of weird. But looking at our scenarios here, I know that if I look at the 2x and I look at the y minus x, those two should be the same, technically. But I don't have one of them in order to solve for the other, okay? In this pair, I have the y plus x and I have y minus x, and these are technically a linear pair, which means I know that they add up to 180 because they're right next to each other and they form a straight line. I'm going to say let's try to solve that one first. Let's try to solve for the y's. Okay, maybe if we know y, we'll be able to find x. So I know that these two, because they're linear, they're supposed to add up to 180. So if I have a y plus x, and then I'm going to add y minus x, set it equal to 180, I should be able to combine like terms to solve. Well, if when I add y plus y, that gives me 2y. But when I take x plus a negative x, well, anything minus itself should be 0. Okay, there is no x left. That's why I end up with just 2y. I went ahead and put my equals before I should have, but that equals 180. Okay, just by trying to combine these two together, the x and the negative x cancel each other out. So then if I divide by 2, y can equal 90. And if y is 90, I should be able to plug it back in and solve for x. Okay, but here's what I have to do. I cannot plug it back into the same equation because in that same equation that we started with, the x has disappeared. Okay, so I can't plug it back in there. I have to use a different relationship. This is where I'm going to go back and I'm going to use this 2x and the y minus x relationship in order to solve for x. So I know that the 2x and the y minus x are vertical. I need to set them equal to each other. So that's going to give me 2x equals y minus x. Well, here's the nice thing. I've already found y. Y is going to be 90. So I'm going to replace it here with a 90. 2x equals 90 minus x. And now I just have x in my equation and I can solve. I need to get my x's on both sides. So I'm going to add this single x to the other side. So I end up with 3x equals 90. I'll be able to divide by 3. And then x should be 30. Okay, now you could always go back and plug all that in and make sure that it all works out, but it should. Okay, so that one's just a little bit more algebra involved. Number 8. So for number 8, we're solving for x, but I have an x up here and an x down here. Okay. It kind of depends on what I can use in order for how I'm going to solve this. Okay. So ideally, I know that vertical angles are supposed to be the same measurement, but currently my x and my 4x minus 10 are not vertical angles. They're not the same measurement. Technically, I need to take this 4x minus 10. Let's say I just move it to the top here. Take this 4x minus 10 and move it up here. And these two are vertical. So I know that if this one down here is 4x minus 10, this one up here is 4x minus 10. And then if I look, I have x, I have the 4x minus 10, and I have this angle over here on the right, what that has a little box. Remember, a little box means 90 degrees. The three of those angles should form a line segment. They should form linear angles. So I should be able to take all three of those, add them together, and set them equal to 180. So that's what I'm going to do. I'm going to have x plus 4x minus 10 plus 90 equals 180. Combine your like terms. X plus 4x, that becomes 5x. Negative 10 plus 90, that becomes 80. Set that equal to 180, and then start solving. Subtract from 80. 5x equals 100. Divide by 5. and 100 divided by 5, x should be 20. Okay. So that one we had to depend a lot on knowing a couple different relationships. First, we had to notice the vertical angles. Then we had to notice the linear angles. Okay. Kind of just depends on what we're getting. All right. Number 9. So we have another scenario we have to solve for x and y. And like I said the other time, we cannot necessarily solve when we don't have both angles. So here's the deal. We're going to try to find, just like in the last one, try to match up some vertical angles so we can move some things around. Okay. Let's say, in this one, it doesn't really matter what direction we go. But let's say I'm going to take this x minus 10, and if I match it up with its vertical angle, that's over here. So I'm going to fill in x minus 10 on this other side. So then that gives me 3 angles that form a straight line. That gives me the 3x plus 6, the x minus 10, and the x minus 11. And because all of them have x, I can set them equal to 180, and I will be able to solve for x. So 3x plus 6 plus x minus 10, x minus 10 plus the x minus 11 equals 180. Okay, all of those form a straight line right here. Here's that straight line. Okay, so combine like terms. 3x plus x, that becomes 5x. 6 minus 10 minus 11. Okay, that's actually going to become negative 15. And then I'll be able to solve, add 15 to both sides. 5x equals 195. Divide by 5. And x should equal 39. Okay, so there is our x. Okay, now here's the thing. In order to solve for y, it's probably going to be the most beneficial if I can pick out a quick relationship for y. Let's put it that way. So I know if y is down here, ideally I want to set it equal to its vertical angle because I know that they're supposed to be the same. So I'm going to set it equal to the 3x plus 6. Okay, so because those are vertical, and that should help me solve. So y equals 3x plus 6. Okay, now here's the thing. We just solved for x. We can actually take that value and plug it in for this x right here. So y equals 3 parentheses. This is where I plug in the 39, then plus 6. And now when I simplify this, I should have the value of y. So y equals 3 times 39 is 117 plus 6. 117 plus 6 should be 123. And that is our value for y. Okay. All right. So again, try to use all the relationships that you can. I know it's kind of tough, but just keep trying to make as many relationships as you can here. Okay, so we should have 3 more examples, 10, 11, and 12. For number 10, let's see here. We're finding x and y. Okay, and I'm going to say let's deal with the x's first, right? If I were to look along this straight line, it looks like the 2/5 x, the 3/4 x minus 2, and this angle, which this angle, they give you that little box, it should be 90 degrees. If I were to take those 3 angles, they form a line, so they should be able to add up to 180. So 3/4 x minus 2 plus 90 plus 2/5 x equals 180. Okay, we need to combine like terms. So I have 3/4 x and 2/5 x. Okay, In order to add those together, we have to remember some fraction rules. So yes, I know we have to work with fractions, but it's good for you. So let's try to add those together. So I'm going to do this kind of up here. 3/4 plus 2/5. Okay, in order to add fractions, remember you need a common denominator. So you're trying to think of something that both 4 and 5 both go into. 4 and 5 both go into 20. Okay, so that's going to be our common denominator. But now I have to balance out the numerators, meaning what times 4 gave me the 20? Well, I know 4 times 5 would give me 20, so I also have to take 5 times the 3 on top, and 5 times 3 gives me 15. Okay, same thing for the 5. In order to get 20, I know I had to take 5 times 4, so that means I need to take 2 times 4 to get 8, and that's keeping all my fractions balanced. Okay, so while we're changing the numbers a little bit, we're not changing how much they're worth. And then I just add straight across. 15 plus 8 would give me 23 over 20. So 23 over 20x. Okay, and just sit tight. That looks a little weird, but just sit tight for a second. I need to also combine the -2 and the 90. That's going to become 88. Okay, I'm going to subtract 88 from both sides. 23 over 20x equals 92. Okay, and then here's where I deal with the fraction. Okay, so think of it this way. The 23 is on top, so that means it's being multiplied to x. The 20 is on the bottom, which means it's being divided. Let's multiply 20 to both sides so that it cancels out this denominator. We don't have to worry about dividing by anything anymore. That's going to leave me with 23x equals 92 times 20. Probably going to get a big number here. That's going to give me 1,840. But now I need to get rid of this 23, so I'm going to divide both sides by 23, and that should give me x. And x would equal 80. Whew. Okay, so I know that was a lot of work. It was crazy. But the nice thing is now that we know that x is 80, we should be able to find y. Okay, so I'm going to say try to pick out the best relationship you can. If I look at where y is located, okay, there's not a vertical angle to y. There are some linear pairs though. If I look at A to B, this is a line segment, which means that y plus this 3/4 x minus 2, those should add up to 180 because they form a linear pair. So I'm going to work this out over here. Y plus 3/4 x minus 2 should equal 180. Okay, and here's the deal. We've already solved for x, right? All I have to do is go in and substitute 80 in there, and I should be able to solve for y. So y plus 3/4 times 80 minus 2 equals 180. Okay, let's simplify those fractions. 3/4 times 80. Okay, now keep in mind 80 as a fraction is 80 over 1. You do not need common denominators when you multiply. You just multiply straight across. So 3 times 80, that is 240. 4 times 1 is just 4. And I can divide 240 divided by 4. That should equal 60. So all this right here just simplified and became 60. So y plus 60 minus 2 equals 180. Combine 60 minus 2, that becomes 58. And then I subtract 58 to both sides. And y should equal 122. All right, so that one, lots of things going on, and I'd say a lot of it's due to the fractions, right? I know that fractions kind of take us a minute, but these are skills that we have to practice. We have to work with fractions. I'm sorry. There's just no way getting around them. Okay. So do your best, but try to remember some rules. So remember when you're adding or subtracting fractions like we did up here, you need a common denominator. And remember when you multiply fractions like we did over here on the right, you just multiply straight across. Okay. All right, number 11. So we have another X and Y thing going on here. And let's see. What would be the best way to go about this? I see some linear pairs. I also see some vertical pairs. So it all depends on what you see based on how you want to solve. So I'm going to say in this one, I think that Y would actually be better to solve for first. And here's the reason. Y is vertical to this bottom angle. Okay, but you're probably like, Miss Kaiser, there's nothing in that bottom angle. That is true. However, I know that this bottom angle and this 68 form a linear pair. Okay, they're on this line CD. So I know 68 plus this bottom angle should equal Y. I could say the same thing about the 68 and the Y. Actually, I probably should have connected those. They're also in a straight line, right? So I know that 68 plus Y should add up to 180. Okay, and if I can find Y, okay, that'll really help me out when it comes to finding X. Okay, so all I have to do is subtract 68 from both sides. Y equals 112. All right, so that one was pretty simple, okay? I saw a couple of different linear pairs that I could work with, and I was able to solve for Y. Now, if I know Y, I should be able to solve for X because I have more linear adjacents here. Okay, so I know that if I were to take Y, which is 112, and add it to the 4x minus 2 and add it to 30, these should form a straight line right here. So that's what I'm going to do. So Y plus 4x minus 2 plus 30 should add up to 180. But again, I can replace Y. I can substitute it in and put 112 instead. Okay, and now the only variable I have to solve for is X, so combine like terms. I have 112 minus 12 plus 30. So 112 plus 30 minus 12 is 154. Plus 4x equals 180. I need to subtract the 154 to the other side. So let's see here, 180 minus 154 is 26. Divide by 4. And hold on, I feel like I added something wrong here. Let's go back. Hold on, let's go back to this combining step. I feel like I did not combine this correctly. So 112 minus 12 would be 100 plus 30. Well, that should be 130. Okay, so something messed up in my math, and that happens. Always check yourself, right? Okay, so now subtract 130. 4x equals oh, see, check yourself again. I wrote down this problem wrong. Go figure. Okay, sorry. Let's go back. Let's go back to the beginning. Let's start with that from scratch. Instead of the Y, I'm just going to write down 112. I already know that it's supposed to be substituted. Okay, so that's 112. What I messed up right here, 4x minus 2. It's not minus 12, it's minus 2, Miss Kaiser. Gosh. And then the plus 30, and then that should equal 180. I apologize. So sorry about that. Combine like terms. 112 minus 2 is 110 plus 30, that's 140. I can subtract 140 from both sides. 4x equals 40, divide by 4. X should be 10. Wow. Okay, so like I said, sometimes we're just going to need to take a minute and slow down and pay close attention to what we're doing because these do take a little bit more time. But that's okay. Like, we're trying to use all the skills that we can and try to make sure that we're paying, you know, as much attention as we can to these. And then we got to our solution. So only one more. Phew. One more, and then we should be done. All right. So in this last one, ooh, lots and lots of things going on. So I have 2x plus 1, I have 3x plus 10, 8 over 9x plus 10. I have a y minus 3, and I have a y. Okay, so I'm going to say we probably need to work on the x's first, because all of these x's, if I were to go from A to B, they are all on this line segment. Okay, so that means all three of these angles right here should add up to 180. So let's go ahead and write that out. 2x plus 1 plus 3x plus 10 plus 8 over 9x plus 10 should all add up to 180. Okay, so if I find this, I should be able to find x, which will help me with y. Okay, so combine like terms, 2x, 3x, and 8 over 9x. So I know the 2x and the 3x are 5. However, this 8 over 9, I need to do my fraction practice again. So let me go over here to do that. I'm going to have a 5 over 1 plus an 8 over a 9. Okay, which means I need a common denominator for 1 and 9. The smallest thing they both go into is 9. Okay, so what's going to happen here? The 8 over 9 is actually going to stay the same. I don't have to change the 9 to get 9, so I don't have to change the 8. For this 5 over 1, I would have to multiply 9 by 1 to get 9, so I need to multiply 9 by 5, and that's going to change it to 45. So 45 over 9 plus 8 over 9, add the top numbers only. 45 plus 8, that should give me 53. And I'm going to leave that as 53 over 9 in my problem. So that's going to go next to the x. 53 over 9 right by x. Then I can combine my constants. So I have 1, 10, and 10. That becomes 21. Subtract 21 from both sides. Oh, whoops. Let's write that a little clearer. 53 over 9x equals 180 minus 21, should be 159. Okay, and then here's where I need to do stuff with my fraction again. Remember, get rid of the denominator first. It's a division. So multiply both sides by 9. That's going to leave me with 53x. And 159 times 9, 1,431. Okay, and then I can divide both sides by 53, which would leave me with x, which is 27. Okay, so I was able to solve for x. All right, which means I should be able to use that to find y. I just have to figure out the best way to go about solving for y. So if I were to look, both of my y's are next to each other, contained in these two angles. So I have y minus 3 and I have y. If I were to look, it does look like these two have a vertical angle, and their vertical angle happens to be the 3x plus 10. So if I take that 27 and I substitute it in for this x, I should be able to find the vertical angle across from the y's. So let's do that. So this is 3 times 27 plus 10. Well, 3 times 27 is 81. So 81 plus 10 happens to be 91. Oh, whoops, 91. All right, so that means that these two angles should equal each other. So let me go off to this. Actually, let me go to the other side so you can still see the picture. Okay. So I'm going to take y minus 3 plus y and set it equal to that 91 we just found. 91. I need to stop writing 90. Okay, combine like terms. Y plus y, that's 2y minus 3 equals 91. Add 3 to both sides. 2y equals 94. Divide by 2. And y should equal 47. Okay. So I plug that into my space over here. Okay, and I have now solved for x and y. Okay, so we got through a lot of examples, but I'm hoping that some of those kind of click. Remember, most of those were all looking for either a linear pair or linear adjacents, which mean they add up to 180. We're looking for vertical angles, which means they should be equal to each other. Or we're looking for all the angles around a point and around, they should total 360. Some vocab to keep in mind: straight angle. If two rays with the same vertex are distinct and collinear, then the rays form a line called a straight angle. And then the other vocab, vertical angles. So two angles are vertical angles or vertically opposite angles. I like that description better. If their sides form two pairs of opposite rays. All right, but that takes care of all of our notes for lesson 6. There are a couple pages after the problem set that I do want to show you or do want to mention. So if I go to, or actually, sorry, if I go here to this post, I kind of attached it later on, but it's after the problem set. It's called Key Facts and Discoveries from Earlier Grades. So I think if you go through these charts, it's just a couple of pages of all these different charts. And basically, they're all rules about angles that you've talked about at some point, or you should have talked about at some point. But I would go through and read through those just kind of as a refresher. And then hopefully, once you're refreshed with those, they'll kind of help with our lessons the next few days. Okay, but that gets us started with lesson 6 and solving for different angles. If you have any questions, please let me know.